Questions 21 through 25 on the 2017 Grade 9 Pascal Math Contest. Each of the numbers 1 through 26 is placed in a different circle below. The numbers 13 and 17 are placed as shown. Jen calculates the average of the first 3 circles, the average of the numbers in the first next 3 circles, and the average of the numbers in the last 3 circles. These 3 averages are equal. What number is placed in the shaded circle? The first thing to do in this question is add up all the numbers that they have given. And when you add up those numbers, then we can divide those in 3 parts. So when you add up all these numbers, you get 111. So 111 has to be divided equally among those 3 sets. So 111 divided by 3. So each of those 3 sets has to have a sum of 37. And that's it. So therefore, this has to have a sum of 37. So that means 13 plus 17 plus that circle, let's say x, is 37. And therefore, x is 7. So this number that goes in the shaded area is 7. And just for the sake of completeness, you can make the other ones 5, 6, and 26. That will add up to 37. And 1, 14, and 22. That will add up to 37. And when you take the average of those, they will all be the same. So number 21, the answer is 7. That's choice D. In the diagram, UVWX is a rectangle that lies flat on the horizontal floor. A vertical semicircular wall with diameter XW is constructed. Point Z is the highest point on this wall. If UV is 20 and VW is 30, the perimeter of triangle UVW is closest to. Well, first let's draw that triangle UVZ, actually. UVZ. So this triangle, as you can hopefully see, this three-dimensional. And because of the symmetry of this diagram, the distance from U to Z will be the same as the distance from Z to V. So when I figure out the perimeter, it'll be UV plus VZ plus ZU. And UV we know, that's 20. And therefore, I really just have to figure out 2 times VZ, since ZU is equal to ZV. All right, so we just have to calculate this distance right here, and then we'll be done with the question. All right, well, the way to do that, first drop a perpendicular from Z down to the base right there. So that's a perpendicular. And then connect that to V. And that, hopefully, you're convinced is a right triangle. And that point I'll just call it O. So that means ZO squared plus OV squared is equal to ZV squared. Now, ZO is the radius of that semicircle. And since the diameter is 20, right, because that's a rectangle, so UV is the same as XW, so that's 20. Diameter is 20, so the radius must be 10. So this is 10 squared. OV, however, that I don't know, so I have to figure that out separately. No problem. I can just use this relationship right here, this triangle. OV squared is equal to OW squared plus VW squared. OW squared is 10 squared, and VW, that's 30 squared. So this is 100 plus 900, so 1,000. So there you go. OV squared is 1,000, so put 1,000 right there. So that means ZV squared is 1,100, and therefore ZV, if you take the square root of that, it will be approximately 33.166. So we're done pretty much. Now P is therefore equal to 20 plus 2 times VZ, or ZV, 33.166. And therefore, that, if you do the math, is 86.33. And that is closest to choice B for number 22. An Anderson number is a positive integer k less than 10,000 with the property that k squared ends with the digit or digits of k. For example, 25 is an Anderson number because 625 ends with 25. But 75 is not an Anderson number because 5625 does not end with 75. If S is the sum of all even Anderson numbers, what is the sum of the digits of S? I just want to give a quick shout out to someone who I know whose last name is Anderson. His name is Greg Anderson. Notice the spelling is slightly different. And he's a legend because this man back in 1987 set the Canadian record for the high school 3,000 meters with a remarkable time of 8 minutes even. And this is what, 2021, 34 years later, nobody has ever come close to this. And I doubt that anybody ever will. And he is now happily living in the U.S., and I've communicated with him a few times over the years, and he's a wonderful person, and I wish him the very best. This question, k is between 0 and 10,000. Now, we have to come up with some sort of a pattern here, right? Because there's a lot of numbers in here, and there's no way we're going to go through each one. So let's break it up. First, let's talk about single-digit numbers. So single digit. So k is, 1, 2, 3, that kind of thing. And that one you can just do manually. If you have k and k squared, 1, 2, 3, 4, 5, 6, 7, 8, 9. Very quickly you can get these k squared values, 16, 25, 36, 49, 64, and 81. As I can clearly see, the only even one, because we're only interested in even ones, in which the Anderson number property holds true, is for 6. 6 is k squared is 36, and k squared does indeed end with the 6. So that means 6 is the only one for the single digits. Now we will move on to double digits. And double digits has an interesting conclusion that we can make from the single digit, that the units digit of k must be 6. There's no other way that this can work if we're talking about even numbers. Because if you look at this table, it's very interesting that when you square them, 6 is the only even number for which this holds true. And therefore, when I have a double digit number, whatever it is, some number with 2 digits, and this could be whatever, and then this is 6. When I square this number, the last number will be 6, right? Because 6 multiplied by itself is 36, and that means the last number is 6. And that's the only number that can go in this column. So now what we have to do is figure out what number goes there. Okay, well, of the double-digit numbers, there's only a few of them that end in 6, right? 16, 26, 36, 46, and so on. 56, 66, 76, 86, and 96. So it definitely helps to know that the last digit is a 6. So these are our options for k. And then k squared, I'll let you do that. We write them all out. And let's see which one holds true in terms of the conditions of an Anderson number. And when I look through this list, the only one, interestingly, is this guy, 76 and 5776. That's the only one. So for the double digit number, again, I've got only one number that works. Okay, in the tradition that we have set, we can conclude that when we're talking about 3-digit numbers, the last two must be 76. So it's the same logic. If you have a number that's 3 digits and it has the last 2 digits of 76, when you square it, whatever the value is, the last 2 digits of k squared will also be 76. And we have shown that over here. Okay, that definitely helps us because now all we have to do is look at triple digit numbers that end in 76. And there's only a few of those, 176, 276, and so on. And these are the options for k squared. I'll let you square all of those. And when you do, the only one that meets the conditions of an Anderson number is this guy right here. As you can see, there's 376 and there's 376 for the value of k squared. So for triple digits, we have 376 as the only one. And again, by now I think you are an expert. We have to go to the last scenario, which is a 4-digit number. And the 4-digit number, the last 3 digits of k must be 376. So once again, there's only a few 4-digit numbers that end in 376, and of course they are 1376, 2376, and so on. These are our candidates for k and k squared. Square them all, and you will find that the only one that gives you an Anderson number is this one. When you square it, it's a big long number, 87909,376. So as you can see, that number ends in that number. So of the 4-digit numbers, the only one that is an Anderson number is 9376. So we had 6, 76, 376, and 9376. So our S is the sum of all possible Anderson numbers. So that's 6 plus 76 plus 376 plus 9376. And that number is 9834. And they want you to find the sum of the digits. The sum of the digits of that number are 9 plus 8 plus 3 plus 4. And that is 24. 24 is the answer to this question. And that would be E. A town has 2017 houses. Of these 2017 houses, 1820 have a dog, 1651 have a cat, and 1182 have a turtle. If X is the largest possible number of houses that have a dog, a cat, and a turtle, and Y is the smallest possible number of houses that have a dog, a cat, and a turtle, then X minus Y is. Well, we have basically to look at extreme case scenarios. And these two Venn diagrams represent those extreme case scenarios. So I'll first start with this one right here and explain what's happening. This is basically a scenario where everybody that has a turtle, which is 1182, also has a cat and a dog. So that is going to represent the scenario in which you have the largest possible number of houses that have a dog, a cat, and a turtle. So we have everyone that has a turtle also has a cat and a dog. Now, the number of people that have a turtle, that's given in the question 1182, so that's why I put the 1182 in the turtle circle. Now the cat, 1651 have a cat, right? So if you minus that in 1182, it will give you 469, and that's what would go here. And then 2017 is the total, and 1820 have a dog, so 1820 minus this 1651 would give you how many go into the dog section, only dog, and that's 169. So that 169 goes here. And then 2017 is the total, and you subtract from that the number that have the dog, 1820, because that's the largest circle, and that gives you 197. So 197 is out here. Those are the people that don't have any pets. So this is the scenario, and therefore, since our number, we'll call it a combination, I guess, whatever, we'll say G is the number that we're looking for. That is between X and Y. And so far we figured out that the largest is 1182. And now we have to search for Y. In this Venn diagram, I'll label it A, B, C, D, E, F, G, where G is representing the people that have a dog, a cat, and a turtle. So this represents the dog circle, this is the cat circle, and this is the turtle circle. So from that diagram, we get a couple of equations here. The first equation is, of course, the everything, A plus B plus C plus D plus F plus G. That's everybody. And everybody is 2017 homes. And then we are told that A plus D plus E plus G, those are the dog people, that is 1820. And then we are also told that B plus D plus F plus G, those are the cat people, that's 1651. And then the turtle people, which is 1182, that would be E plus F plus C. All right, so where do we go from here? Well, a few things we could do, of course. We can add them all. And if you add them all, you get A plus B plus C plus D plus E plus F plus G. And then we get plus D plus E plus F plus 2G. And that total is 4653. Well, this segment here, that's 2017. So we put that in. Therefore, 2017 plus D plus E plus F plus 2G is 4653. And therefore, D plus E plus F plus 2G is 4653 minus 2017, and that would be 2636. Okay, so I will call this equation 1, this guy right here, and this equation 2. And now what I'll do is just subtract them, 2 minus 1. And when I do 2 minus 1, I get the following. I get G minus A minus B minus C is equal to 619. So that means G is equal to 619 plus A plus B plus C. And therefore the minimum value for G will happen when A is 0, B is 0, C is 0. So that means A is 0, B is 0, C is 0. And that's the minimum value. And if you really want to, you can fiddle around with these equations to get the value for E, F, and D. It's not necessary that you do, but you can. And if you do, D will be 835, F will be 197, and E will be 366. But G, the minimum value, is 619. So there we go. 619 is the minimum. So now all we have to do is figure out x minus y. X is 1182. That was the maximum value for G, which represents all the people that have a cat, a dog, and a turtle. The minimum was 619. So 1182 minus 619 is 563. And therefore, number 24, the answer is C. Sam thinks of a 5-digit number. Sam's friend Sally tries to guess his number. Sam writes the number of the matching digits beside each of Sally's guesses. A digit is considered matching when it is in the correct digit in the correct position. What is the sum of all possible values for Sam's number? All right, so we've got to do some analyzation here. Okay, so let's start. Let's see what we can get. Well, the first thing that caught my attention is this one right here. That 0. So that means 7 is not going to be in the first digit, 1 is not the second digit, and so on. And then when I looked at this one, it looked very similar. Now, 7 is not the first digit, according to this guy, so it can't be the first digit here. According to this guy, 1 is not the second digit, so therefore 1 is not the second digit there. 7 is not the third, 7 can't be the third. 9 is not the fourth, so therefore 4 perhaps is the fourth. 4 is not the fifth, 4 is not the fifth. So when you look at those two, that means that 4 must be the fourth digit. Because, just to repeat, none of these are correct. And therefore, 7 is not correct, 1 is not correct, 7 is not correct, and the last 4 is not correct. The only one, by process of elimination, that must be correct is that 4. So that one, when you look at those two, it helps you conclude that the fourth digit must be a 4. So we're done looking at that one, we're done looking at this one. Okay, now let's look at all the other ones. So the first one is 515405. So 5, 1, 5, and then 5. We won't write the 4 because 4 has already been established. And the number of matching digits is 2, but since the 4 we know matches, I have to now figure out which one of the remaining of these 4 is the other matching digit. That's why I put a 1 there. Okay, the next number is 21531. So 2, 1, 5, 3. I'm going to skip that and just put the 1 because the fourth number is 4 for sure. And one of those matches. Okay, the next one, this one we don't need to do because that has already been established. None of those are right. Then we've got 5, 9, 1, skip the fourth one, and 5, only one of those matches. And then the next one, 5, 8, 3, 4, 2, only one of those matches. And finally 3, 7, 3, skip the next one is 8. There you go, only one of those matches. Okay, now let's discuss this. So now I've got to look at this and try to figure this out. Well, we established that the fourth number is a 4. Okay, now let's look at this guy. I'm going to start by saying the first number is a 5. We got to start somewhere. So I'm going to establish that. I'm going to say the first number is a 5. That means the one correct is this guy. Now the next number, it cannot be a 1 according to this one, remember? None of those are right, and it has 1 in its second position. So the next cannot be a 1. So I'm going to put that here, not 1. And then if this is the only one that's correct, then that means this is incorrect, this is incorrect. So the third one is not a 5, and the fifth one is also not a 5. In this scenario where I have chosen 5 to be the first digit. Okay, let's go to the next one. Only one of these is correct. Okay, well the first one has already been established as a 5, so that means this cannot be a 2. Okay, well this one we know it's not a 1 because that was right there. If you remember right here, 1 cannot be the second digit. And then, so that takes care of that. 5, well, the third digit is not a 5, so that's wrong. And then 1 for the fifth digit, that's the only other option. That's the only option that works for there to be one of these correct. So that must be the fifth one. Okay, we've established that as a 1. Great. Let's keep going. This next one, 5 is the first digit. Okay, that works. That's what we have actually. 9, well, only one of these can be correct. So that means that the second one cannot be a 9. And then therefore the third one cannot be a 1 because only one of those can be correct. And the fifth one, well, we already know that the fifth one is a 1. All right, great. Now let's go to this one. 5, yeah, 5 is the correct one, so that's great. So that means the second digit cannot be an 8. The third digit cannot be a 3. And then the other two have already been established. And then the last one, the first one, is definitely not a 3. That's already been established to be a 5. And let's see here. The second digit could be a 7. I'll just put that there for now. The third digit, it can't be a 3. So this is gone. And then the last digit, well, that's already been established that it's a 1. So obviously it's not an 8. All right. So that means it has to be a 7. That's the only way that's going to work. Okay. So we've established a pretty decent amount of work here. The only thing we didn't get was the middle one. So the middle one obviously looks like it could be anything except it cannot be a 5, a 1, or a 3. So let's write out all these numbers. These numbers will be 5, 7, 4, 1. And the middle digit is going to be either a 0, a 2, a 4, 6, 7, 8, or 9. The only thing it cannot be is 1, 3, or 5. But the rest of the digits are the same. So I hope you understood how I was able to figure that out. I tried to explain it in a way that is digestible. So these are the numbers. Okay, let's add them up because we have to figure out the sum. And that sum is 402,887. Now, is that one of the answer choices? No. It's less than the answer choices. So that obviously means that we have to discover more. Now, before I go on and discover more, I want to double check if any of these if all of these work. And when you go through these, you can easily double check. But there's one that falls apart that has to be disqualified. And it's one that has a 7 in the third position, because this is a very important one. None of these can be true. You cannot have a 7 in the first position, a 1 in the second position, a 7 in the third position, a 9 in the fourth position, or a 4 in the fifth position. So if you look at these numbers that I just wrote down here, one of these falls apart, and that is this one right here. This one right here, 5, 7, 7, 4, 1. It has a 7 in the third position, and that is not allowed. So that one I will subtract. And when I subtract that, 5, 7, 7, 4, 1, my new total is 3, 4, 5, 1, 4, 6. All right. Let's move forward now. Let's go to another scenario. So we're going to proceed in pretty much the same way. We have already established that 4 must be that fourth digit. So now, just as before, we're going to go and see what we get for everything else. Just how we did over here. So we've got 5. Remember, the second digit cannot be a 1 according to this guy right there, so I'm just going to skip over that. 5 and 5, and only one of those is correct. Then from the next one, very similar to I did over there, 2, 5, and 1, only one of those is correct. Then 5, 9, 1, 5, only one of those is correct. And then 5, 8, 3, 2, one of those is correct. And finally, 3, 7, 3, and 8, only one of those is correct. Okay, let's work with this. 1, 2, 3, 4, 5, and the fourth one is a 4. Now, if you recall, in the previous one, I had set that to be the true value for the first digit. Now I'm going to select this one to be my one that is correct, because remember, 1 is correct. So that means this guy cannot be a 5, and this guy cannot be a 5. All right, so we got that taken care of. Now let's look at the next line. 2. Can 2 be the first digit? Perhaps, but 5 has already been selected as being the correct third digit. So that means this cannot be a 2. So that's the only way this can work. And therefore this cannot be a 1. All right. Now, next one. Only one of these is correct. Let's see which one. Can't be this because this one cannot be a 5. It can't be this because that one cannot be a 5. We've already established that. The third digit has already been established as a 5, so it's obviously not a 1. So by process of elimination, this must be a 9. Okay, next one. Only one of these is correct. Let's see which one. It can't be this one because that cannot be a 5. Well, it's not an 8 because that's already been established as a 9, so that one's gone. This one is wrong because it's already been established as a 5, and therefore by process of elimination, that must be a 2. And then let's look at the last one. I guess that's just a 3. That's the only way this is going to work. And obviously this is not going to be a 7, this is not going to be a 3, and this is not going to be an 8. So we got all of them this time. So we got a number 3, 9, 5, 4, 2. Great. So 3, 9, 5, 4, 2, when you add it to 3, 4, 5, 1, 4, 6, it still falls short of the answer choices. So that basically means I got to keep going. I've got to make a few more. All right, let's try to make a few more. So in the same style, we are going to do the same thing again. We have established that 4 is the 4th term, and we have to now do the same analysis as before. Only one of these is correct. 2, 5, 1, only one of those is correct. 5, 9, 1, 5, only one of those is correct. And 5, 8, 3, 2, only one of those correct. And finally 3, 7, 3, 8, only one of those is correct. Now if you recall, for the first one I had set this guy to be correct. For the second example I had set this guy to be correct. So obviously for this one I have to set the third 5 to be correct. So there we go. I put that as my choice. So that means that obviously if I were to write this number out like this, this is a 4, this is a 5, and therefore this cannot be a 5, and this cannot be a 5, since only one of these is correct. Okay, let's keep going. Next line, 2, 5, 1. Well, the last 5 has already been assigned, so it's obviously not a 1. This one, we've already established it cannot be a 5 for the middle number, so by process of elimination, that must be a 2. So we've assigned that now. Next one, 5, 9, 1, 5. Well, this is obviously not a 5. This perhaps could be a 9. Let's just put that in for now. I'm not sure if it is. Maybe, maybe not. This perhaps could be a 1. Oh, there we go. This is a 5, and this is a 5. So that means this is the one that's right. And therefore, this is not a 9. And therefore, this is not a 1. All right. Let's go to the next one. Only one of these is correct. Which one? Not a 5. It's not this one. This one has already been established as a 5, so it's not that. So it's not a 2. So we got an 8 or a 3. Okay, so 8 or 3. And then the last one, only one of these is true. Well, obviously it's not this one because we've already established that to be a 2, so not 3. It's not the last one because that's already been established as a 5. And then we've got either 7 or 3. 7 or 3. Well, the only way this can work is if this third digit is a 3. And therefore, that second digit is open to be several choices, but the only thing it cannot be is it cannot be a 7 or an 8. So there we go. We got some more. So let's write out these numbers. 2, 3, 4, 5. And the second digit can be anything except 7, 8, or 9. So it can be 0, 1, 2, 3, 4, 5, 6. And of course, all the other digits are the same. All right, let's do our test now. Let's see if any of those get disqualified or not. Remember, you cannot have this 7 in the first position and so on. And if we look at that one, there's one that gets disqualified, and that is when you have 1 in the second position. That is not allowed. So that would be this one right here. You can't have this one because that one has 1 in the second position. So I'm going to just add up the other guys. And that total is 142070. All right, so I think we've got it. We have this one, 3, 4, 5, 1, 4, 6. We had this one over here. Don't forget this guy. This 39542. 39542. And then, of course, we just got this one. This 142070. And then when you add up all these guys, the grand total is 526758. 526758 is this choice. Choice E for number 25.